a historical approach is good. So maybe Marcus, you could go. I see we're live now. Awesome.
Okay.
Yeah, yeah. We have no viewers yet, so we can still kind of. Yeah, so I'll do a brief interview, welcoming everybody, and I will allow you guys to give just a few minutes, a few second, whatever, kind of introduction of yourselves, and then we go into the subject matter. And a lot of times I may just throw something out there, and whoever wants to pick it up first, well, whoever feels more comfortable to answer it can just jump right in.
All right, and Farrell, in terms of everyone else knowing that we're live, are you sending out a link now? Is that it?
Yep. Mm-hmm. Yep.
Okay,
yep.
cool.
So they'll know. The group will know.
All right. Oops. All right.
Hey, so did they ever confirm how many people with family islands? What happened with them? If anybody died or anything like that?
Oh yeah. Apparently, there's been no loss of life directly related to the hurricane. So a lot of those, I guess, those WhatsApp messages and the stuff that was being passed around was just rumors.
What about the cargo ship? Did they find that?
No, I don't think they found that yet.
I mean, because I saw some people on Facebook say that they had family members in those islands who died. So I don't know.
Yeah, I mean that was so messed up yesterday. I don't know how those rumors started, but apparently, the official report from the Commissioner of Police is there's been no loss of life that he can confirm.
I'd be surprised, but we'll see.
Yeah.
Yeah. Did anybody take the bait yet?
Yeah. Okay. So we have we have a few viewers now, so we'll get the ball rolling. So good morning or good afternoon, everyone. Hope you're having a wonderful Sunday. And you should be in church right now, but you're not. Anyway, surprise, surprise. But welcome to, I can't remember exactly which session of BFT Hangouts this is, but we're getting up there. I think we're getting close to 10. But this one is dedicated to one of the more controversial theories out there, especially as it relates to the Bahamas, seeing that we're still stuck in the Stone Ages and some of our beliefs, but the Big Bang Theory. And this is, I think this is, in my opinion, one of the most revolutionary, one of the most important scientific theories out there that's been discovered not relatively recently, and it explains a lot that was previously unknown. So we're going to dig a little deeper into it today, and I'm happy to have two of our awesome active members of BFT. We have Chris Jenkins and we have Marcus Dean, two very, very, very sharp minds in their own right. So they'll be digging a bit deeper into the Big Bang Theory and trying to unravel it a bit for some of our the more novice scientists like myself, and I'm pretty sure a lot of other people out there. And I've warned them that they must break this down into layman terms, and if they start to get a little too deep, I'll try to pull them back so we can understand, because I know I don't understand all that jargon. But they've promised to behave well. They're ready to get into it, and I'll give them both an opportunity just to quickly introduce themselves. Chris, if you can go ahead.
Sure. My name's Chris Jenkins. I'm an attorney. I'm Bahamian, but I was born and raised in the UK. I've lived here 10 years. I am by no means a scientist. I've had pretty much no formal education in these fields at any serious level, but I'm an enthusiastic consumer of science in general, and particularly astrophysics. So I hopefully will be able to communicate as a layman, because I am a layman, and hopefully we can learn something about how the universe, the origins of the universe.
Excellent. Thank you so much, Marcus.
All right. Yeah, basically the same. I'm a layman. You've probably seen my name time to time with cartoon avatar. Well, this is me right there. So I get but you shouldn't really have to worry about me getting too technical or too deep, because, like I said, I'm not really a scientist. I'm more of a science enthusiast, and I'm not afraid to say I don't know. And if it's too much, if it's too much detail, I'd rather pique your interest so that you could go research it for yourself.
Excellent. All right, guys. Thank you so much. So, for me, I've referred to the Big Bang Theory. I'm do you say I believe in the Big Bang Theory, or do you say I'm a subscriber of the Big Bang Theory, or you just or it's just a fact, so you run with it? How do you identify as someone who accepts the Big Bang Theory? What's the proper saying? I've always been kind of confused by that.
To me, I think you really. I mean, I wouldn't say that you believe in it, but I think you say that you believe it happened as far as the evidence is concerned, from what the expert physicists have gathered. And even now, it's still an idea propagated by humans, so that there is always a chance that it's not entirely a complete picture of what we believe happened in the beginning of the universe. So there's always a chance that it could be wrong, but until the evidence comes to actually obliterate it and smash it to pieces, there shouldn't be any reason to not accept it as a valid explanation to a certain degree.
Yeah.
I think it's not really a matter of belief as such. The fact is that the Big Bang Theory, as it's come to be known, is mainstream scientific. It's accepted by mainstream science, and it has almost universal acceptance now, where the evidence is at the moment. Whereas previously there were competing theories. That there have been certain sort of discoveries that have essentially, put the matter pretty much beyond doubt, albeit with some serious questions remaining in the theory, but which we'll come to.
Because like I was saying, I often refer to it. I use it as a basis for the universe's existence and ultimately human existence. Many times in my debates, and which it happens pretty frequently, obviously, because we know that we live in a very Christian culture. So previous to the Big Bang Theory, I think unfortunately most people, their default position was whatever regional religion was prevalent in their area. That kind of was the prevailing reason or explanation for the universe's existence. So that's why I think this is one of the more controversial scientific discoveries. I mean, it really just smashes and puts to bed all the different dogmas and the different mythologies and religions out there. So we get a lot of pushback as scientific persons. We get a lot of pushback from the religious persons out there. But I've never known enough about it to really break it down and to make someone else who previously may not have subscribed to it not a believer in it, but for them to understand and accept it as fact. That's something that's always been really challenging for me, and I'm pretty sure a lot of people out there. So that's something that I hope that at the end of this discussion, I am, and the persons that are viewing this are a bit more better equipped for those type of debates. That's important for me. So one thing I want to start at was what was in the scientific world, what was the prevailing view for the existence or the existence of the universe before the Big Bang? I don't know if any of you kind of delved into that. But because scientists, I think they've kind of always rejected the religious folks from a while ago. But what was the accepted reason for the universe's existence prior to the Big Bang?
The accepted reason, well, it depends. There was some, like say Isaac Newton, who believed in a God, but there were some who believed basically the prevailing viewpoint is basically two camps scientifically. Either the universe was always here as it was, it was unchanging, or it was created, but it was created as it is now. But before the Big Bang, there really was no idea that the universe expanded from a singular point. So either it was always eternal as it is now, or it was created as it is now. So that's basically the general viewpoints of what it was.
And I think it also depends on the time which
Right.
you're talking about. So let's not forget that even the existence of the universe is a relatively recent,
Right.
phenomenon.
Right. So I mean, if you don't mind, I'm getting that a bit as well, because I want to go like all the way back to ancient Greece, where the idea of cosmology not really first came from, but that's just a starting point I want to go to. So basically, and we say basically 340 BC, during the time of Aristotle in ancient Greece, he made the proposition that the Earth was a sphere and not a flat disk. And two the reasoning he used was that when you have a lunar eclipse, you would see the shadow of the Earth on the moon, and that wouldn't have been possible if the Earth was a flat disk. It would have been a completely different type of shadow. And also that when people travel at night in the south, the northern star that basically is, you can see almost directly over the North Pole, it is much lower in the sky than if you were in the north. So those were two of his reasonings, and various other things that people were able to justify that the Earth was a sphere and not flat. So it's contrary to popular belief. Even as far back as ancient Greece, there were people who understood that the Earth to be a sphere, not flat. But he had his view of the universe is that, you know, it was the Earth at the center, and all the heavenly bodies, the sun, the moon, and the stars, which they considered fixtures in the sky, basically rotated around it. And in the second century AD, you had Ptolemy. He expanded on the same concept, and he created a model, but basically the same universe where the Earth was at the center. And he had this idea that there was an outer sphere. So even though the universe was not big, it was limited, but he never really expanded upon what was outside of this so-called outer sphere. So, and the idea of, and it was, and of course the church pretty much liked that because that fit right in line with Genesis and stuff like that. So they didn't really have a issue with that particular view of the world. So geocentrism reigned for a while, and he was able to somewhat accurately predict the positions of the heavenly bodies, even though he had to make several different caveats, and he knew that, they were kind of flaws in this system, but it was accepted nonetheless. And it wasn't really until like around 1514 with Copernicus when he proposed his model of the universe with the sun at the center instead of Earth. But of course, during the time, he was afraid of the wrath from the church, so he published his findings anonymously, and it didn't really gain too much traction until after his death. It was picked up nearly 100 years later by Johannes Kepler, and of course, we know the name Galileo.
Yeah.
We know Galileo because he was the inventor of the telescope. I don't know if he's the inventor of the telescope or if he made a refinement on the telescope. Either way, he was able to use his telescope to, what caused him to actually accept Copernicus's model of the universe is that he used his telescope to view Jupiter, and he noticed that Jupiter had moons orbiting it, and so he came to the conclusion that if Jupiter has bodies orbiting it, then it really can be that Earth is the center of the universe, and maybe there is something to this idea that the Earth is orbiting the sun. But of course, it was very limited. They as far as they're concerned, nothing lied beyond Jupiter. And of course, Kepler, his idea was basically that he was able to calculate the orbits of the planets around the sun, and he basically came to the conclusion that they were elliptical, like more like an egg shape, in orbit as opposed to a circular orbit. But he didn't really like that explanation because he considered circles to be more elegant for some reason than ellipsis. But he wasn't able to, even though his calculations matched an elliptical orbit, he wasn't able to explain why planets and all the stuff would move in an elliptical orbit. And it wasn't until Isaac Newton came and he published his work Principia Mathematica, where he proposed the law of gravity, as well as calculus and all that stuff that basically explained that different bodies attracted each other, and that was the force that explained orbit, that how planets revolve around the sun and all that stuff like that. But a problem that he was concerned with was why don't stars fall into each other. So his idea was that the universe was infinite, and so as such that means there would be an infinite amount of stars, so that there would be no central point for them
Marcus,
to fall.
let's let Chris catch up a bit on before we get into the Big Bang and the inception of the Big Bang. I want to just speak about the history before that. And thank you so much, Marcus. Chris, you want to jump in?
I was going right to the 20th century, and that was it. So that was
okay,
going.
all right.
20th
All right.
century. So,
Go ahead, Chris.
No, I was going to say I think this is actually very helpful background. I was going to let Marcus carry on, bring us up to the 20th century. Obviously, I'll chip in with details as and when, but I think this is really informative and very helpful.
Yeah, no, it has been for me big time. Okay, let's get to the Big Bang theory itself. Who and when was it discovered?
All right. Well, at the time. So let's go back to and perhaps Marcus will come back to the sort of the lead up to this. But what we're talking about here is the very origins of the universe. And by the universe, just so we all know what we're talking about everything. The universe is the term for everything that there is that we are aware about, and it contains smaller things like galaxies, and within those solar systems. But we're talking about everything. So where did everything come from? And there were two sort of main theories at the sort of start of the 20th century, the main theory, I should say, is called the static universe. The static universe was the idea that at any point it's infinite, and at any point in time, the universe is essentially the same as it is. It's infinite, but it had no beginning, has no end. And that idea, I think Marcus already mentioned, that idea was first put forward by a maverick Italian called Bruno, who anyone who follows the Neil deGrasse Tyson series Cosmos will recall, probably I think from episode 1 or episode 2, as having been imprisoned and then burned at the stake for his ideas. Now he thought that it was the he viewed it through religious eyes. So he saw the infinite universe as just an expression of the infinite power of God, the Christian God at the time. Now, the problem with Bruno's idea was he had absolutely no evidence whatsoever that the universe was infinite. Actually, that didn't come till later. But Einstein, who's most well known for his the theory of general relativity, which is his really the successor theory to Newton's physics on the motion of heavenly bodies, and much more accurate. He was a subscriber to this static universe theory. Now that started to take a couple of dents as the 20th century wore on, when a couple of pieces of observational evidence contradicted the theory of this static universe. The first of those is an observation first made in 1912, which basically noted that what were then called spiral nebula, but we in fact know them now to be galaxies, appeared to show what's called a Doppler shift. Now, that sounds complicated, but it's not. What a Doppler shift is if you can imagine like an ambulance is coming towards you, and it makes its noise, it hears its sirens, and then it goes past you, and you know that the sound of the siren to you changes. It becomes lower as it goes past. Now, what's happening there is the sound waves, because of the motion of the ambulance as it goes past, the sound waves appear to you to be lengthening as the source of the sound wave goes away. It's coming towards you. I think Marcus is very helpfully holding up a picture, of a Marcus. Perhaps you could.
Marcus, hold it up. I'm gonna throw Marcus' camera up there so we can. Go ahead, Chris. You can talk. They see Marcus' camera, I think.
All right. So it looks like Marcus and I have done the same research here, which is very, very helpful. But Marcus has got an excellent picture there of some Kyle's drawing of a car.
But I think this illustrates the point, Chris. So if you can continue on with your ambulance example.
So we don't lose the track here. So, and exactly the same thing happens with light, and that's I'm just spitting on my screen. Exactly the same thing happens with light, and what it does with light is, again, as Marcus's picture very well shows, that if something is coming towards you, it sort of squishes the light waves up, and it tends it towards the blue end of the light spectrum. Now, on the other side, if it's going away from you, it tends the light towards, from its natural position, towards the red end of the light spectrum. And that is called a Doppler shift. Now, that was first noticed in 1912, and the scientists who found it didn't really know what it meant. And that didn't come until a little later, in the 20s, from the probably unlikely source of a Belgian priest called Georges Lemaitre, who proposed that what this meant was that the universe was expanding, which itself was a pretty revolutionary thought at the time. And he reasoned later that if you follow that logic, that means if you wind time backwards, an expanding universe would mean that previously it was much smaller. And you take that logic all the way back to its logical beginnings, and you've got what he called a primordial atom, which we know today as a singularity, a gravitational singularity. And I think the next, and Marcus, chime in if I'm out of sequence here, but I think the next big development in this theory was basically is it Edmund or Edward Hubble?
Edward Hubble. Yeah, yes. Edward Hubble, basically 2 years after him in 1929. And just to go back a little bit, the scientist who you mentioned from 1912, his name, well, he was an American scientist by the name of Vesto Slipher, VestosliPher, who you mentioned from 1912. And, basically, Edwin Hubble, even though he's credited, in the first, he wasn't really the first. It was a combination of Lemaitre and Hubble's discoveries. But it was basically Hubble. He was credited because when he viewed it through the telescope, he was able to observe redshift as well, and that's where he was basically credited with the discovery of the redshift of galaxies and expansion of the universe and stuff like that.
What we did was, what Hubble did to get to a next level is as any good scientist does, he takes this theory, tests it, and he tested every known redshift that they could find, and the data was all consistent. And what he found was that there was a correlation between the distance of a celestial body, a distance of a galaxy from us, and the amount of redshift, so which meant its speed. So the further away the things were, the faster they were going, which again is entirely consistent with that. and that correlation became known as Hubble's law. So that's when you got the sort of the kernels of the Big Bang Theory. Now,
so Chris, if I could just kind of sum up where we're at right now. So it was discovered that the universe was I mean, I'm just going to put it in very simple terms. You guys correct me if I'm wrong here. So it was discovered that the universe is expanding, which means that if it's expanding, if you take the reverse or the inverse, it means that you can literally take it right back to a beginning point. Is that,
yeah.
you know what I mean? Am I kind of like, am I oversimplifying it?
No. Only slightly. The point is not only were the galaxies, we're talking on a galactic level here, so the galaxies outside of our own Milky Way, all of the other galaxies that were, visible or observable at the time. This is a time when galaxies are starting to be discovered in great numbers. They are all expanding, firing away, but they're doing so in a predictable way. And the further they are, the faster they're going. And those are the ingredients that allow you mathematically to take it all the way back.
And that's where we are. Okay, I just wanted to kind of just sum where we are right now.
So one of the problems with Big Bang Theory, it was certainly not universally accepted at the time, and as Marcus said, the term was actually used pejoratively on a BBC interview by a chap called Foyle. He was basically saying, "What, you think this is all just one like Big Bang, right? As opposed to the grand idea of an infinite and static universe."
Yeah.
And it was actually leapt upon by the church of all people at the time, or several members of the church, are saying, we told you so. This points to a creation moment. I mean, of course, it doesn't, but the religious like to simplify the idea down to it was just a moment in time where, boom, bam, creation occurred at the finger of a deity pressing a button somewhere. So that's kind of where we got to, and the problem with it was that one of the sort of consequences of the theory was that it predicted what's called a cosmic microwave background, which would be essentially the sound or the waves created, not sound waves, but waves created by the Big Bang, this rapid expansion, and those waves were, because they would have been so old, would be right at the bottom of the spectrum of waves, a spectrum of light.
Light waves.
Which are microwave. We know them as microwaves. Now, what then happened was there was I believe, again, Marcus, you probably got more detail on this. Did you look at this?
Yeah. Basically, in the 60s, there's a pair of scientists by the name of Arnold Penzias and Robert Wilson. They discovered the evidence for a cosmic microwave background, because basically, if you look up at the galaxy or galaxies with a regular telescope, it would be just pitch black because you won't be able to see them with the naked eye. But like Chris said, the radiation would be at the bottom of the light spectrum. It would be on the microwave background. So using a radio telescope, they were able to detect the faint glow, and it was uniform. No matter where they looked, it was uniform. It wasn't emitting from any particular source, like say a star or anything like that. And basically, that was the evidence that they found for the cosmic microwave background, for basically left over from the Big Bang, from the first, I guess, say 300,000 years after the Big Bang. And basically, I mean, I have a little paragraph about it. They say basically when the universe was young, before this formation of stars and planets, it was a lot denser and hotter, and it was filled with a uniform glow from a white-hot fog of hydrogen plasma. So as the universe expanded, both the plasma and the radiation filling it cooled off a bit. And when the universe cooled enough, um, basically protons and electrons, sorry, combine to form neutral atoms. And and after a while, they couldn't absorb the thermal radiation, so that's why the universe became more transparent and foggy. So that's where you could see straight through it, and that's one of the reasons why it's more. You can't really see it with the naked eye. You would need special tools to perceive it. So yeah, that's one of the other stuff.
And that's where the microwaves originated from. But the story of the discovery of these things in 1965 by these guys it's quite an interesting one, because I think they weren't looking for this. They were looking for something else, and they kept getting this. They were using I think the most powerful telescopes that were around at the time.
Radio telescope, yeah.
Radio telescopes, and they kept trying to find this thing, but there was this weird interference. So the guys got out and literally got onto the dish of this radio telescope and scrubbed it clean. They just did this a couple of times to try and remove any dirt or anything that might be causing this interference. And again, I'm a little fuzzy on the exact story, but I don't think that they realized immediately what they'd found was the sound. That they were listening to the Big Bang, just coming from a very, very long way away. From 13.4 billion light years away.
You guys, you have to appreciate how difficult that is for us persons who may not be as learned as you are in this particular subject. So what you're saying is they heard the Big Bang.
Yeah. So if you look up at the sky, what you're looking at is you're looking into the past. Okay. So you look at the sun. You're not actually looking at the sun. You're looking at the sun 4 minutes ago. Okay. That's a simple example.
Yeah.
If you look
4 to 8 minutes, yeah, basically.
Yeah, you're looking at the light that left the sun. But I think maybe it's 7 minutes. So it's a number of minutes ago. If you look at Mars, so when we get people to Mars, if they were to shine a very 7 minutes later, if Pluto blew up, okay, and there was an explosion, you would look into the sky 4 hours after that explosion and see that explosion happen. So when you look up to the sky, you're looking into the past because of the nature of light. It has a speed. It's the maximum speed limit of the universe. Nothing goes faster.
And it's a constant.
And also, I guess, when you combine it with the vastness of the distance that we're dealing with these heavenly bodies, I think sometimes we take it for granted that these things aren't as far away as we think they are, but really, I mean, we're talking about massive and massive amounts of distance between us and the things that we see in the sky.
Right.
Yeah, and it's mind-boggling.
Right, because there are stars out there that might not even exist anymore, and we wouldn't know about it for tens of thousands of years, because that's how long the light emitted from them.
But we're still seeing their light though up in the sky.
Yeah.
They might be gone by now.
And as telescopes have become more powerful, we've been able to see things that are further away and also further back in time. So our nearest galaxy is Andromeda, and that's something again.
I think it's 2 light years away.
I think it's a little more than that, but if it's an appreciable length of time for light to travel. And there's you fast forward, and there's a famous picture taken by the Hubble Space Telescope a number of years ago, which I think is one of the most amazing pictures ever taken of anything. And it's called the Deep Space Field, where the Hubble concentrated on a tiny area of the sky where there didn't appear to be anything, and left its cameras and it's everything rolling on that tiny piece of sky for ages. And when they looked at the results, they saw millions of galaxies, some of which date, almost back to the beginning of the universe. They're that old.
And the Hubble telescope, that's like, I think is that the most powerful telescope that we have in existence to date by NASA, I think. Is that correct?
Yeah, I believe so. I believe there might be. I think there's more than one Hubble telescope. If it's not most powerful, it certainly is one of the most powerful.
I think it's the most powerful optical.
Yeah, optical
telescope. I think, but I'm not sure. I'm not sure on that one.
Yeah, and one of the impressive parts of it is the fact that it's in orbit, correct? So it takes much clearer pictures and it sees much further, opposed to having to deal with all the interference with our atmosphere with our land-based telescopes.
Exactly. And you get some pretty good stuff from land-based telescopes, but they usually have a very different format. Radio telescopes, or they have sort of clusters and networks of telescopes that essentially work together and use some fancy maths to stitch the data that they collect together so that it presents one picture.
So currently, the Big Bang is in the scientific community, which is a pretty responsible and very strong and strict self-policing community, by the way. It's the accepted explanation for the existence of the universe.
Well, I wouldn't go that far. It's the accepted explanation for what happened after the.
Yeah.
That's what it. Sorry, I'm not explaining that very well. But it's the accepted explanation for the expansion of the universe to what it is today, or to the existence of what we see today, and what's going to happen in the future, and what happened in the past, right down to tiny fractions of a second.
Yep.
That's probably the more accurate. Now, what came before?
Well, Chris, I was about to get into that, because I was going to say that we know that currently the Big Bang theory it doesn't really gel or meld with a lot of the religious philosophies out there. It's really opposing. But one way that the religious folks, they try their best to incorporate, I think pathetically, but nevertheless, they try their best to incorporate the Big Bang into their dogma, is that it was whichever respective regional god it may be, it was their god that started the Big Bang. Because truth be told, currently, I think we don't know what happened before the Big Bang. How would either one of you respond to that if they said, look, well, there you go. You see, you don't know, so it was the Hebrew God that started the Big Bang. That's why he's real, and that's why we follow him. Because science, you don't have the answer. Sorry.
Yeah, I mean that's really sort of trying to shoehorn
right
where it doesn't fit. The most sort of the biggest logical problem with that is, well, what created the god or gods that?
Right. Because I mean, there's nothing in it that really could stop them from doing it, but it's just superfluous. It's really unnecessary, and there isn't really evidence to support it. But if it helps them sleep at night, there's really no. If they really want to believe that's what happened, because at the end of the day, all the calculations from the different physicists they only go as far back to the first microseconds after the Big Bang. They don't really go to the exact point when it happened. So it's very honest to say that nobody really knows what started it, what caused it, whether it was.
I was going to ask, are there some theories out there in terms of some things being proposed or explored in terms of what started the Big Bang? Or what happened, I guess, what happened seconds before the Big Bang?
Yeah, actually, like I was mentioning before, I watched a BBC documentary a few months back where they interviewed several different physicists about their ideas of what happened pre-Big Bang, because from when the Big Bang became the accepted theory for the creation of the universe, for a very long time, it was almost nonsensical to try to ask what happened before the Big Bang, because as far as they was concerned, it was to say that time didn't exist for the Big Bang, so it wouldn't make any sense. But more and more recently, say like in the past 10 years or so, it's become more and more acceptable for scientists, for physicists to ask these type of questions. And I believe it was already posted in the group before, but I think YouTube took it down. But I posted it again. But basically, I took some notes on that because I rewatched it recently, and basically they interviewed the theoretical physicists. First of all, Michio Kaku, which I think some of y'all might have heard of. The Japanese American theoretical physicist. He's been on different talk shows like Daily Show and stuff like that. He kind of like Neil deGrasse Tyson, like a mainstream of science basically. And his idea was there are two types of nothing. When they say that the universe it came from nothing, because it really is a logical problem. How could a universe come from nothing? So his idea was there are two types of nothing. There is the nothing that is absolutely void of anything, space-time, physics, and then there was another type of nothing, which is basically energy, but there's no matter. And there's he used the example. He went to a facility that NASA uses when they want to simulate space conditions, where they have several days and they pump out the entire room. They suck out all the atoms and they pump everything out so they can simulate the conditions of space. When they want to before they send anything up in space. And he used that facility as an example because there are still things that of course, you still have cameras viewing the experiments and whatnot. So what are you saying that there's a certain in the second type of nothing where there's only energy? Sometimes when the energy condenses, they briefly explode and form matter. And according to him, what could have happened was there was a chain reaction of those type of explosions that culminated into the Big Bang. Now, of course, he admits this is just a hypothesis. It's not something that he staunchly believes, but it's something that is an idea, that could give gravity to what came before the Big Bang. There's another scientist his name is Andre Linde from Stanford University. He's a professor at Stanford University, and his idea was that the Big Bang theory is basically it's flawed, and it's flawed in the sense that it gives an incomplete picture, because of course it's the same problem. Where did this? His idea was explosions usually are messy things. When you see something explode, it's not uniform. It's just everything goes all over the place. So his question was, how can an explosion cause an expansion of uniformity? Because basically, when you look out into space, no matter where you look, everything seems to be the same no matter where you look. So when you go here, you look there, they look the same. So his question was, how could a universe this large be this uniform from an explosion? When he did his calculations, his idea was that after the initial explosion of the Big Bang, there was this property of the universe called inflation that allowed for it to expand relatively quickly. And after a while, this inflation ebbed off to the regular, expansion that we see today. So basically his idea is the expansion that we see today pales in comparison as far as speed is concerned than his idea of inflation. And then over time, as he did even more calculations, he came to realize that, the further back he went, you don't even really need a Big Bang. And he came to this conclusion, I wouldn't say conclusion, but he came to this hypothesis that in the void, there's a void that the idea of inflation is infinite, that in the void infinitely produces different inflations. What that basically says is that in this particular void, there's an inflation of a universe, and that would mean that there's a multiverse, because this void produces this. Like he used the analogy of Swiss cheese, and if you apply heat to Swiss cheese, different bubbles tend to pop up here and there and stuff like that. So his idea is that we exist in there's a void that infinitely produces these inflations, and as such, that would mean that there are multiple universes out there, like basically multiverse theory, and that's his idea about it. Of course, that still goes back to what exactly initiated, this multiverse, and that's still a question to be answered. And of course, there was some physicists find this intriguing, and then there's some who don't really like that idea.
But truth be told, guys, we're still. I know, especially the religious folks, and even some of us, we expect humanity to have all the answers at this point. If you
Right.
don't have the answers, something is wrong. It means that, see, religion wins. We are right. But really and truly, we're just at the beginning of our journey into the universe, and kind of our explorations and understanding how things came to be. And we're really just babies in this journey, correct?
Right, and I'd say that's what I love about that documentary, because none of the scientists were married to their ideas. They did the calculations to lead them these conclusions, but they were amenable to change, and so they did not marry to it to be like, oh, this is what it is, and blah blah blah. And like I said, there was another physicist by the name of Param Singh, and what he did was, it's the same. All of them stem from the same problem, something coming from nothing. And so his idea was I think they worked on the problem for a few years, and they were able to combine Einstein's. They came up with an equation where they combined Einstein's theory of relativity with quantum gravitation, and he basically had it to basically the basic idea is that as the universe expands, eventually it contracts to a point and expands again. So it's more like a cycle of constant expansion and contraction and expansion and contraction. But of course, it goes back to an infinite loop. So where did this first start? And that's still an idea that that's still a conclusion that would escape even someone who came with an idea like that.
But because we know that we're still in our infancy in
Right.
terms of our knowledge of the great beyond, is it possible for 100 years, 200 years from now, for this theory to be completely turned upside down, and so, we make contact with maybe some ancient civilization, hundreds of thousands and millions of light years back into the past somehow, and they basically break it down for us and explain how it came to be? Is that possible, or is it highly unlikely that this is incorrect?
I want us to be honest. I don't really know. I don't even know if it's a problem of whether it's of intelligence or not. I don't even know if we're cognitively capable of understanding something as, because either way you look at it, whether it be an infinite regression or a starting point, is always gonna. I don't know if it's something we could actually comprehend. So I mean, we could probably write it down. And intuitively comprehend, I should say. We could comprehend it in an abstract, but intuitively try to put it into words. I'm not sure if we could actually grasp it, and unless, like you say, some ancient aliens really do come and break it down to something that we could.
Well, Chris, you want to chime in?
Yeah, sure. There are a couple of kinks in the theory, and they are big kinks. And when you find these, when you have a theory and it fits some of the observational evidence, but not all of it, then there's always the possibility that there's going to be a successor theory that explains all of it. Now, in this case, the problem with the current version of the Big Bang theory, before I go there, perhaps we should just bring us up to date slightly from where we got to. So we've got basically the 1965. These guys discover the cosmic microwave background. Okay, when they clean their telescope, they're still hearing the noise. That's what they're hearing. But the next step comes when they started to measure the rate at which galaxies are accelerating, are moving away from us, right? And the problem that they then found was these things are not just moving away at a constant rate, they are accelerating, which no one predicted. In fact, the leading thought was saying that that shouldn't happen. And the reason that they said that shouldn't happen because there is simply not enough stuff in the universe that would account for that. There's not enough energy and there's not enough matter. So what they've had to do to make this theory match the accelerating evidence is they've had to come up with two concepts. One is dark energy, and the other is called dark matter. They're two completely different things. Dark matter is stuff. It's just stuff that doesn't emit light, that light travels straight through, and doesn't appear to react with anything that we know. But we know it exists, or we think it exists, because of the gravity that it produces, which you can see through telescopes. You can see the effect of it on other celestial bodies, and you can also see it in an effect called gravitational lensing, which is where the gravity bends the light of very distant galaxies. So we think that it's there, but we can't. No one's ever seen it. No one's ever measured it, and all we've got are tantalizing little hints that it exists. So that's what.
There's no direct evidence here for it.
No direct evidence. That's right. And the other thing is dark energy, which again you need to make the mathematics work. You need this theory called dark energy, which accounts for something like 75% of the stuff of the energy in the universe, but we don't know where it is. Don't know anything about it, or know very little. But that there's two hypothetical concepts that we need to make the theory work and match all of the observational evidence. Now, that doesn't mean that it's wrong. It just means that there will be refinements to the theory, but that's true of all scientific theories. They're refined as they're developed.
Marcus, you wanna share anything there?
Yeah, it's just one more of the scientist who had his own theory, his own idea. Basically, his name was Lee Smolin of the Perimeter Institute in Canada. Was a leading physicist institute in Canada, and his idea basically is that, and he used Darwin's natural selection as an analogy, in that how all organisms basically they're here to propagate themselves and to reproduce. So that in his analogy is that universes tend to propagate themselves and reproduce, and his idea was that they reproduce via black holes. Because his reasoning is that with a black hole is basically a dead star that is collapsing on itself, and it becomes more and more dense as the gravity becomes stronger, and is after a while becomes to a point where not even light can escape it, and it condenses to a point, and it often expands and contracts and expands. And his idea is that inside a black hole, if you were able to survive going over the event horizon, and the event horizon is basically the point at which the gravity of a black hole would suck you in, and you can't escape it. And of course, you wouldn't survive. It would just stretch you out, and it'd feel very long, but it'll stretch you out and you'll die. But you say, supposing that you could survive it, you just end up in another universe. So his idea is that the different black holes that we see, they have just they're self-contained universes, and our universe exists within the black hole of another universe, and so on and so forth. And that was his hypothesis about. So in that case, it wouldn't necessarily the Big Bang wouldn't be the beginning. It would just be a continuation, and so on and so forth. So that was his hypothesis. So those different alternative theories about what might have happened before the Big Bang. But like I say, none of these guys are married to these ideas. They're not dogmatic about it. They're quite amenable to change, basically, as far as their words. So.
There was one other thing I wanted to
Yep.
talk about that we that might sort of explain a little bit about the Big Bang Theory in a broad way. And that is how we got from something expanding to what we have now. What were the stages of that thing, which Marcus has talked about, the early stages of that, where you got the first, like, very basic particles forming in very, very early on, and that you have this very short phase of much more rapid expansion of space. That's called inflation. Now, Marcus mentioned that that occurred in actually a short amount of time. And what I wanted to add to that was, when we're talking about a short amount of time, we are talking about a fraction of a fraction of a fraction of a millisecond. So things got big very, very quickly. And then, after that had happened, the rate of expansion of the universe became relatively constant or predictable.
And Chris, let me just chime in right there. I think it's important for us as human beings is, again, we kind of have to open our mind a bit in terms of the concepts of time and distances when we're talking about these type of things, because for us a second is almost the smallest kind of a measure of time that majority of us could relate to. But I think that the Big Bang, the initial bang happened, the initial expansion, I mean, in like a fraction of 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 a second. I know for a lot of us that's very difficult to process and comprehend. How can it takes my car 5 minutes to explode, and it's just my car. So how in the world can a universe explode or expand in a fraction of a fraction of a fraction of a second?
Well, when you're talking about cosmology and cosmic events, time is not a constant in the way that we see it in our day-to-day lives. It's relative, and it's as for example, as you approach the speed of light, if you could do that, time would slow down, and it would become infinitely long. And at the speed of light, time doesn't move at all. So what I'm saying there is that you really have to open your mind to some really weird stuff when you're talking about astrophysics. And time itself is not the constant. It's not a tick tock that we see it as.
Yeah, it's not intuitive.
It's not intuitive. It's completely counterintuitive. The idea that time may stop if gravity is, strong enough and that sort of thing is just.
And I think that's one of the advantages the religious folks got over you guys, right? Their stories are so basic. Their theories are so easy to comprehend that even a 5-year-old child can kind of understand that, God made the planets.
Well,
God
did
this. So it's compared to the much deeper theories and concepts that you'd have to come to accept when you talk about the scientific explanation of so many things, including the Big Bang.
That's right. And what's one of the things about science is, we shouldn't trust our senses. Our senses have evolved over millions of years to deal with our specific environment. Finding scientific truth requires us to step outside of the things that we feel are right because we're used to hunting, ancient beasts. We're not designed really to think about these deep questions, and that's why it seems so counterintuitive. That's why it seems wrong, and that's why it's very easy for religious folks to reject very strange sounding scientific truths, and also why a lot of religious stuff is very easily consumable. It's designed and has evolved to be easily digestible by people. But with science, you have to kind of step outside of that, and scientists will become accustomed to feeling sort of uncomfortable or feeling comfortable with dealing with stuff that is not intuitive at all. And an even better example of that is when you get into quantum physics, because that is so counterintuitive that they say if it's intuitive to you, that means you haven't properly understood it.
Yeah, it reminds me of a quote I've heard. I can't remember the name of the scientist who came up with it, but he basically said that not only is the universe stranger than we suppose, it's stranger than we can't even suppose.
That's right, exactly. But just back to, I was just trying to explain what it means when you've got this expanding something, I'm trying to just explain very broadly what that means in terms of going from this period of expanding sort of primordial stuff to what we have today. And I won't go too much detail into it, but there's a few stages that happened. So you've got this period called inflation, where space very rapidly expands within fractions and fractions of fractions of a second. Then you've got the first photons forming, which Marcus already talked about. Then you've got nuclear fission beginning within, I think that happened within 0.1 of a second of the Big Bang. Then you have that was nuclear fusion beginning, and nuclear fusion ending 3 minutes later. And then you've got between 3 minutes and then 380,000 years, you've got the period where there's this cosmic microwave background just flying out everywhere. And during that time, you have the first atoms forming, which were the simplest, which was hydrogen and helium from the nuclear fission. So I'm into the. You have to correct me if I get my numbers here wrong, but I think for millions, potentially even billions of years, there was nothing else in the universe other than hydrogen and helium. Now, that was a problem that didn't make sense to a lot of people for the very good reason that we know that today there's a lot of other stuff. It's not just hydrogen and helium.
Well, does this go back to the whole point that you hear so much in terms of a rebuttal for the Big Bang, is that how can something start from nothing? Are you kind of tying that into that? Are we getting there?
Not really. Where I'm going with this, just to explain it, is that it was everything. So hydrogen and helium coalesces. The gravity of it coalesces. Okay, so you've got all these atoms floating around in this space that's been created, floating around, and they coalesce due to gravity, right? They come, and then more and more coalesce. You get clouds of hydrogen, and when it becomes strong enough, the forces become strong enough, one of them ignites. Okay, and that's the birth of a star. Okay, what stars do? Stars have nuclear fusion, which then essentially the light's turned on in the universe. So you got nuclear fission? I can never remember which one it is, but they create helium. All right, so you've just got these two elements for ages and ages and ages, and it wasn't until the theory tells us that the temperatures of the Big Bang and the early universe simply weren't high enough to create any other of the elements. They weren't powerful enough to fuse other things together, fuse atoms together to make the larger elements like oxygen and carbon, all the stuff of life. And what they discovered was, and I don't know who discovered it or when, but the only thing that could possibly do that was when a star dies. So a star, which is just hydrogen and helium, gets to the end of its life, the gravity is so large that it shrinks in on itself and explodes. And inside, you can show mathematically that the pressures and the temperatures inside an exploding star are what created every other element that there is. So, and again, it's a famous quote that scientists or science enthusiasts love. We are all star stuff. We are all made from these supernova, which is the exploding star, and just sort of completing it as you've got stars igniting all over the place, and as stars ignite, there's all this stuff around them that floats, and that too coalesces into planets orbiting around, and stars and planets forming solar systems like ours, they coalesce around each other, and those are galaxies, and there are billions and billions of galaxies all speeding away from each other, and that takes us essentially up to where we are now.
Marcus, you want to chime in on anything there? Or did Chris do a good job of summing it up from the beginning to the end?
The only thing to really go beyond that is that, whether or not this universe is the only universe or a part of a multiverse, but for right now, that's really just more on the hypothetical for the most part. You know, we wouldn't really know if it's the only universe or is a part of a multiverse. So that's really
I mean, the truth be told, I mean, there's just so much unknown still out there. There's so much we don't know. There's still so much further for us to go into the universe and to learn about the origins of the universe. And do you guys think, if you think about where we were 1,000 years ago or where we were 2,000 years ago in terms of our exposure, and this is actually going to tie into a question, by the way. We're going to get into question and answers in a minute. I have two questions I want to throw out to you guys. But if we think about where we were 2,000 years ago or 3,000 years ago and where we are now, um, for you guys being so into science, does it fascinate you where we may be 1,000 years from now, where we maybe be in 3015 in terms of what we're doing, what we
as long
know?
as long as we continue on this trajectory and we don't blow ourselves up. But yeah, I guess. I mean, it's really. I mean, as long as we continue this enlightenment age and we don't regress into another dark age where you have knowledge, knowledge being burned and shunned and stuff like that, because there's really no real reason to think that this could continue on, the constant building of knowledge, because there's always been points in civilizations where something happens and knowledge becomes regressive and it builds up again and stuff like that. Civilization gets decimated for whatever reason, stuff like that. But I say, as long as we continue on this path, then yeah, sure, I'm stoked to know where knowledge goes 1,000 years from now.
And I think it's become too widespread now. That the internet has really sort of put knowledge out there available to everyone. I mean, previously you had to be relatively wealthy or very, very lucky to have access to the few books that there existed in the few tiny centers of learning in the very small, civilized world that has, existed in the past. But now it's universal. And obviously there are some places where the environment isn't particularly conducive to learning, where you've got religious regimes,
But that's probably only a matter of time as well.
Yeah. No, I agree. I agree on that.
Okay, so I have two questions. Well, let me throw these questions out to you guys because we're at 12:15, so we kind of have to start winding down. But let me throw one of these questions out to you guys. I'll just read it. And this is from Nicole Roberts, another one of our very active members. If we have all this knowledge about the universe and how it began, why is it that so many find the very idea of an infinite universe too incredible to understand and embrace?
Well, I think, firstly, because as we discussed, it is counterintuitive, right? That's one thing. And secondly, I think that most people haven't really sort of scratched into this subject and started exploring some of these amazing ideas and theorems. But I think that's something that's starting to change because we're living in an era now where it's the sort of the age of the science communicators in many ways, the people who are starting to popularize what are difficult concepts but amazing ones, and it's catching on, and it's people like Neil deGrasse Tyson in the States, Bill Nye, who's been doing it for years, Carl Jung, who did it, Carl Sagan, who did it, before. Yeah, and in the UK you've got Brian Cox, who's sort of the British version of Neil deGrasse Tyson. But these things are starting to become much more and more popular. So I think you're going to start to see the age of disbelief almost starting to change, and people are starting to open their minds, and it's down to effective communication of science, using the power of technology, using drama, using highly produced shows and visuals and things like that.
And also, but the question itself is kind of flawed in that Newton, like I mentioned earlier, Newton, he came up with the idea. Well, I wouldn't say he came up with the idea, but he propagated the idea of an infinite universe in order to make his idea of gravity, not the stars not falling into each other, work. So he did believe in an infinite universe, and that was basically one of the prevailing beliefs of the universe before the Big Bang came along. Because, like I said, the guy who came up with the pejorative term Big Bang, Fred Hoyle, he was a believer in a static infinite universe. And eventually he came over to the side of the Big Bang, as was Einstein. Einstein was against us first as well, but he eventually um, recanted and he came along with the idea of the Big Bang. But yeah, so the idea that intuitively is difficult for the grasp, but there was a scientific view that the universe was infinite and unchanging. So I wouldn't necessarily say that it's hard for us to believe the universe might be infinite. It just so happens that the evidence that that initiated the Big Bang theory went against the idea of a static infinite universe.
All right, let me throw another question out to you guys. So I think, Marcus, if you remember in the beginning, we went as far back as ancient Greece, I think. So here's the question, and this was also from Nicole Roberts and from Nicole Bedford and Quentin Larota as well. You know, a great believer, a champion Christian. Hey, Quentin. um, the question is, if we go further than ancient Greece, we would see that the cosmology of the ancient Mayans, Egyptians, Sumerians, and Dugons was quite advanced, much before European astronomers. So would you guys agree? I know there's a lot of talk out there that these guys had a great understanding of the celestial bodies and the orbits and that sort of stuff, and they used them in the designs of their pyramids. Would you compare what we know now to what they knew then, or is there even a comparison?
I mean, I wouldn't necessarily have, well, all right, I don't really have anything to say against what they brought up. I mean, the only reason, to be honest, why I even started at that point in ancient Greece is because the other day I was reading Stephen Hawking's A Brief History of Time, and that was the first person he mentioned. I mean, I know, of course, the Mayans and all these other ancient civilizations that predated them, who had all these different ideas about the universe. And I didn't start off with the ancient Greeks to say that they were the pinnacle or anything like that. That was basically just a random starting point. Because to go back to these different civilizations is a topic within itself. And I was just trying to make it as brief as I could, for time. So it wasn't really anything against those cultures or anything like that.
But I mean, oh, sorry, go ahead, Chris.
Oh yeah, these guys, the ancient civilizations, they are limited in a way that we are not. They're limited in what they can look up, and they can look at the sky and they can deduce certain things. They don't have telescopes and and radio telescopes, and they don't have thousands of years of accumulation of mathematical understanding. We've got tools today that put, and a lot of these guys may have come up with some ideas that turned out to be right, but some of these things are guesswork, right? They're just natural inferences from what they see, from what they observe, and relevant to them, and in that context. So they can write down something that may have been a guess, and I'm speaking from a level of ignorance here, because I'm not entirely certain exactly what theories are put forward as evidence of that, but essentially a lot of these things could have turned out, like, for example, like Bruno in the 16th century, to have been an intelligent guess, which is cool and shows that you're on the right lines, but it's not science, it's something else.
And I think people may fail to realize that those ancient civilizations, I mean, they spent a lot of time looking at the sky. That consumed a lot of their lives. It was probably one of the most fascinating things to them, just simply because of their lack of understanding. So maybe, like you said, Chris, maybe they did get some things right, compared to relative to the amount of time that they spent studying those celestial bodies. So I think, and both you and Marcus said the same thing. You're not necessarily taking anything away from what they may have achieved and how advanced they may have appeared at the time, but truth be told, I think, Chris, you hit the nail on the head. They have great limitations imposed on them in terms of the technology that was available to them compared to what we have now.
Yeah. And also, I want to bring up too. There was an Egyptian. She was a female scientist who lived in. I believe they say she was a Greco-Egyptian. She lived in about 1st or 2nd century AD in Egypt, and I remember watching a documentary on her, and she was also someone who who was able to calculate that according to our calculations, that the Earth revolved around the sun as opposed to the geocentric model. But a lot of her works were destroyed, and she was eventually killed by, I believe it was the early Christians, who burned a lot of these libraries in Egypt because they considered them pagan. So a lot of her works were lost. Her name was Hypatia, I believe. Like I say, she was one of the people who calculated the Earth revolved around the sun before Copernicus did, and Galileo and stuff like that. But a lot of her, like I said, a lot of her works were lost when they were destroyed, and she was eventually killed.
Well, I was just looking at some of the comments on the Facebook page, and I can see that there was a comment from somebody saying essentially, why do we discredit the ancients in favour of the moderns? And what I would say to that is that firstly, what people describe as ancient really isn't very ancient at all. Okay, on the sort of the grand scheme of modern humanity, you've got to go back way further to realise how modern even things that how modern ancient Egypt is.
Right.
Because Egypt is a relatively advanced civilization coming just before us on the grand scheme of time. After humans were travelling around the world 90,000 years ago. We're talking the ancient Egyptians. We're talking 5,000 years ago.
Right.
And also, to finish the thought, what was started then, when writing is invented, is starting to build a body of human knowledge. And all we've done over the years is built on top of it. Now, there have been times along the way where some bodies of information have become lost and had to be rediscovered again. But we're way past that now. All we're doing is we're building on the foundations that were put forward, and not just things and facts and theories, but methods. The scientific method, we're building on all of these things. It's not a matter of ancients against moderns. We're all part of the same team. They were just playing their part in the game a little earlier.
Yeah, it's one continuum.
We benefit from it.
And just to build on this point about how recent the people we consider ancient is. I remember watching Cosmos, and they had the history of the universe as a 12-hour clock, and basically 24-hour clock. Sorry, was it 24 hours? 12? Yeah, 24-hour clock. And basically, if the beginning of the universe was 12 o'clock a.m., human beings, our modern form of human beings came on stream, say 11:59 p.m. and when agriculture was developed, basically in writing, and what we call civilizations developed, and everything since then was like in the last, say, 30 seconds until midnight. So that's how recent even stuff like ancient Sumerians, ancient Egyptians, and the Mayans are compared to our history as mostly hunter-gatherers up until probably like about 10,000 or so years ago, because that's how recent it was.
I mean, it's important that again, of course, that pales in comparison to the scale we're talking about when we talk about the cosmos, but it is true. I mean, even on that level, as human beings, so unfortunately, one thing that religion has done to us, I think it's screwed up our sense of time and our scale of time, even on the earth itself. So everything was when the Bible, 3,000 years ago, at most 6,000 years ago. So it kind of really skewed our understanding of the human journey. Because I think you're so right. I mean, what we consider ancient history now is not really ancient history relative to how long we have been in existence as human beings.
And there's a good book I commend to anyone. If you want to get a good snapshot of human history, it's called Guns, Germs, and Steel, and it takes human history back from the last 90,000 years rather than the last 5,000, which isn't ordinarily taught in textbooks to kids. But as you say, Farrell, we as humans, and it's not just through religion, just intuitively, our brains do not need to understand 1 billion years. We don't need to know what that feels like. For us, 100 years is a very long time. but cosmologically speaking, it is a blink of an eye.
Yeah.
And but we're not evolved to deal with those measures of time. We don't gain any evolutionary advantage from understanding how long evolution has taken to occur on Earth, or how old the universe is. So it's always going to be something.
Although, Chris, as it relates to us maybe having a disaster of epic proportion, like some type of meteorite, or understanding the large orbits of certain celestial bodies that may threaten our Earth, maybe there's an evolutionary advantage to understanding how those things work and understanding what a billion years is.
I say this: there was an advantage to understanding it. It's not an evolutionary advantage. Evolutionary advantage compares you to another member of the population.
Correct.
You would gain an evolutionary advantage over your neighbor by something.
Because like I say, most of our brains are mostly
advantageous. There's no question about that.
Yeah, definitely. Marcus, go ahead.
No, because
I'm gonna ask you both to just Marcus, you can start, but let's just kind of give you like a wrap-up statement, because we have to kind of end the broadcast just literally in a minute or two. So, Marcus, if you could start and just if you can sum up as quickly as possible what you would like for all the listeners and everybody who's going to watch this after, because not only the persons that are on right now, a lot of our videos, they get a great deal of views afterwards. So all the persons who are going to watch this and hear your contribution, what would you like them to take away from it at the end of it, please?
Well, you can take away from it is that, like I said at the beginning, I'm just a science enthusiast. I'm not a scientist. I'm just saying I'm trying to explain things from my understanding. And if these type of things intrigue you, I suggest that you do further study. Even something as simple as Google, and books like by Stephen Hawking or Neil deGrasse Tyson or Michio Kaku or any of the notable physicists, astrophysicists would be good places to start. So I think this should be like a starting point in your journey of knowledge, if anything.
Perfect. Thank you, Marcus. Chris?
Although the topic of the origin of the universe is absolutely mind-blowing and fascinating. There's no question about it. It's not all easy, but it's amazing stuff. I would point you in the direction in terms of a good, easily consumable source. Look at the Cosmos series. It's
right. Yeah, Cosmos.
It breaks it down. Also breaks down, as we've tried to do a little bit, the history of how our ideas have got to where they are. It's a great thing. I'd say it's suitable from probably about 12 years up. Fascinating stuff. But go away and do some research, do some reading, watch some cool TV, and pass on your enthusiasm to someone else as well when you've got there.
Okay, perfect, guys. I want to thank you guys both for taking part in this. For me, it was a fascinating conversation. I've learned a lot. I can't wait now to take on the religious folks. That's kind of a hobby of mine. Outside of the sanctuary of BFT, I fight a lot of battles. So thank you very much for giving me that added ammunition that I need for today. This is my special day. But I'm very. Thank you so much for giving us your time and your knowledge. And also, too, there's a post that's pretty live for both of you guys in BFT right now about this particular Hangout. So we're conversating about the Big Bang Theory. So if both of you can maybe jump on it and continue the conversation if you can, we'll appreciate it. But thank you so much.
Yeah.
And to all of our listeners and all of our viewers, thank you so much for taking part. Another very successful BFT Hangout. Chris, Marcus, we really appreciate you guys.
All right, peace.
Pleasure.
Thank you.